Hi everyone, and welcome to my lightning talk. Today I'm going to be talking about understanding how your application is built and how that makes for better testing, giving you the knowledge to feel confident in how you go about breaking down your application so that you can make much better tests. But firstly, who am I? I'm David. I head up developer advocacy here at BrowserStack and also run the open source program office. I'm a Selenium committer and a Appium contributor. I chair the W3C's browser testing and tools working group, which is where the WebDriver specification and the WebDriver BiDi specification lives. So with that, let's get started. When we start thinking about our applications and how we go about testing it, generally people come at it from somewhat of a black box. They look at what are the processes that they need to follow, the steps, and they might be storing this in some form of test management system. And do they go step 1, step 2, step 3? And by the time they get to them, what they see is what you see on your inside your browser or on your phone or on your smart device. We built this up, making sure that we know exactly what we need to test and the steps that they are. But understanding what happens underneath and how all of these components comes together is far more valuable when it comes to testing, because we start to realize that we don't need to test the whole or an end-to-end, but we can start testing components, the small bits and pieces. That way we can have fewer end-to-end tests, which by kind of doing that removes some of the flakiness that will naturally just occur. Because flaky tests has nothing to do with your framework, but understanding how the application works under the hood. We have asynchronicity, we have networks, we have all of this. And these things impact how we go about thinking and building our test frameworks and our testing and our tests. So if we look at how a product is generally built, we'll get an idea of something that we want to build. In this case, a father's playing with his daughter. They're going to build the greatest tower in the world. But each one of those parts is just a component. And you string together components. So if we take this into how our web applications or our mobile applications are built, these components could be different widgets within the UI, different microservices, different ways that the data gets from the database all the way back through to the end user. And so, as with generally with software, you'll have someone fairly senior, someone fairly junior working together to build the application that gives them what they want. In this case, the tallest tower in the world. But as we can see, they're building it up. Not all the components are the same color, but luckily they hook in together. So if we take this down to a web component model or kind of front-end application, all components easily hook in together, but it doesn't necessarily mean, in this case, a straight tower. The tower starts leaning, things start going wrong. And it's not necessarily the fault of the developers or the fault of the testers. It's just an inherent thing that happens when we're building our software. Another way to look at it is that when we look at software as a whole, we tend to see it as somewhat of a forest. These forests are just huge ecosystems in their own right. If we take a web component, for example, or even like any front-end component that could even be used to build mobile applications, we start to see that like they are their own ecosystem in the same way that each tree is its own ecosystem. And when you put it all together, they can either work symbiotically or they can start to fight each other off. And they slow things down. Trees don't walk around because then that's not what they do. They just kind of live, they make their point in that place at that time. And then we go further. But when we go about testing it, we don't want to test the entire forest. What we want to test is a single tree in isolation. So if we took this from a web application, we would start to look and see how that component gets into the front end. Developer tools within browsers are great at how this works, and you can actually see in and peer. But knowing what components are being put together before you've even looked at it allows you to start creating component tests instead of an end-to-end test. So you only test that component in isolation, make sure it's okay. It can still be its own ecosystem. It can still render. It can still do these amazing things. And it also creates this isolation. The more isolation that we tend to have in our applications when testing allows us to then have better understanding of our tests. Our tests can then easily be sharded, because if we start thinking of everything in isolation, we start to create atomic tests by just naturally. Those natural atomic tests can be parallelized, which now means your longest running test is how long your test suite needs to run, because you can shard it. You can send it up into the cloud, either through your average CI/CD system or something like BrowserStack, where you just need to kind of use real devices or real browsers. You can start running them in a meaningful way. And suddenly our tests become faster, more stable, less flaky, and easier to fix as they change. Developers start to get a better understanding of what a test looks like, because now they can focus in. If they're only on that component, they fix that component test at that time. And so tools are an easy way to learn. People get fixated on it. But understanding what your application is doing under the hood, how it is doing it, leads to a newer sense of how to go about testing it, a stronger sense of how to go about testing it, so that you have more confidence in what you're doing and how you're doing it. So hopefully you found this really useful. My name's David, and hopefully I'll see you soon. Thanks.